Okay, so in order for my anticipated student difficulty section, what I've done is we're looking at the pitch angle of roofs. So what I've done is I've got my 2015 question from the Leaving Certificate exam, and we're told this roof structure with four faces, and it's you can see from the plan elevation that we're told. So just simply redraw our plan elevation. We have a 3D image of it above. And what I'm focusing on for this question is I'm ignoring my dihedral angles and I'm ignoring my true shape of surface C. I'm going to skip down to part D, part 1. I'm just going to help alleviate student difficulties by looking at determining the pitch of surface A. So what we mean when we look at the pitch of surface A is the angle produced by surface A to the horizontal plane. Okay, so I'm going to just zoom out here. And what I've got here is I've got my question redrawn. I've got my plan rotated, and I've got my elevation projected up. So we can see surface A here is going to be here. Now, what I've actually got done is I've made the 3D model in order to help students visualize what we're actually looking at. So, looking plan, we can see surface A is going to be here. We're looking at elevation. So our elevation is going to be kind of at an angle like this. So we're looking in directly kind of, and we'll see surface A directly. So what we really need to do, right, is what we're really looking to simply is we're going to look at the angle in order to see something like that. In order to see the angle produced by surface in here, surface A to the ground. There's going to be an angle touching between here and there. So, okay, so let's go back to my drawing files. So we're told that surface A, and when we look at surface A, the next section we're going to do is from surface A, we can see that no line on the surface is a true length line. And how do we know that? Well, from we're talking about auxiliaries, in order to see the true length of a line, it has to be either parallel to the XY line in plan or elevation. So this line here is not parallel in the plan or elevation. This line is not parallel in plan or elevation, or this line is not parallel in plan or elevation. So what we can do is we can draw a line along surface A. So what we would do is we could get a line and we would draw it from the point P along surface A. So along here, that would be parallel to the XY line. So it'll be straight across. And what we can do then is we can find that point lies on the surface. So we've got a new line P to the line, and we can bring that down. And what we do then is we can find where it touches the point of intersection between the apex and the ground. We'll join it back to point P in plan. And what that is, this line here, this new line, is a true length of this line in elevation. So if we look directly down, we'll see this line here as a true length as it cuts across the surface. Okay, so that means now we have a reference point in order to project our first auxiliary view so that we can see our surface as an edge view. So what we do then is simply, what we do always is we project up our surface and we create our plane, our x1, y1, that's perpendicular to this line of reference, and we bring up each point on the surface. So we've got a point here, we've got point P, and this point lie along that point, and we've got this point up here. So we have a surface, right? So x1, y1. Now, in order to see the surface as an edge view, we simply just take our heights back up from our xy line. So we're given our heights in the question. We'll say we're told at a scale of 1 is to 100. So what I did was I come up 60 and I come up 16. So it's going to be 60 and 80. And we'll mark our points off. And we'll mark our points off the x1, y1. And then what we can do then, as a result, is we can draw a line view so that we'll see our points from our P, the height of P and the height of the apex on our surface. We'll draw them back through each other to draw them back to the x1, y1. And what we get is the angle in here. And what that angle is, it's 60.26. But from that would more so be, we'll say 60 degrees, is this angle produced in here. So we can see that the pitch of surface A is 60 degrees So therefore, we can see now that surface A produces an angle of 60 degrees to the ground. So I feel that that this model could be used very beneficial to help students realize what exactly they are looking for when they're asked to find the pitch angle of a surface.